Okay, we're back. And also, the y-intercept happens to be the v0, the starting speed, when we launched it. And again, I don't even know, what is the apparatus looks like. So part of it is we're going to have to possibly alter our technique. So the slope happens to be also v0. And that is in cm per second. That's not as critical, but we should recognize it. So we can now do this. And borders. Now, let's see if I was clever enough. So let's take this, and we're going to copy. Oops, no, we want to get everybody. Yeah. And we want to copy. And want to paste. Yep, and paste everything. Now let's take a look. All right, we gotta see, gotta clean up some errors. And yeah, M6. So it didn't work. We want it to be M, this one here, M21. So, I guess there's no good way to do this. So we'll just delete it. So M21, and then the y-intercept, and then we need to fill it in. And circular, okay. Oh, I know what. I forgot to put the dollar signs. So hit the F4 key once. Put the cursor there, F4. Okay. Nice. And let's put the grid. And of course, I'm sure you've noticed we have something going on here. But let's take a look. So we select our T. And now we hold the control key down. And we select our speeds. And then we insert chart, scatter plot. There we go. All right, that looks fine because we're going in the opposite direction. So it's negative. Let's see. So I want the maximum to be 0. There we go. Give us a better perspective on it. And now we want to add the fit line. Add fit line. X values are the times. And the Y's are the fit lines. And we say OK. And I can't even see it because, let's take a look. And obviously we have to change things. So we double click. And first of all, let's take care of this. So on the solid line, and I'm going to make it thin again. And we want marker to be none. There we go. And now we can start messing around. So it looks like in this case, at least the y-intercept is going to be -5. And now we can go back to this being, well, let's leave it here for the moment. And let's see. So we need the slope is a negative. We need it to be a little bit more positive. So let's get rid of the 5. Ooh, interesting. And I played a little dirty trick on you guys that I'll go over in a minute. So this graph needs some jazzing up with the titles and such. But let's take a look at this. So we notice that in both cases we have a negative acceleration. Now, in the case of going in the reverse direction, we notice that the speed, the magnitude is increasing. And in this case, because we're above the line, the speed is decreasing. And so we're going to have a little bias in our measurements. And what we want, ideally, would be if the accelerations would be equal. And so, so what we want to, let's add another one. Here the difference, DIFF equals tab. And let's see, does it matter which one is which? If they're negative or not. And, right. I know it's, give me a minute, just let me pause this for a moment. All right, so now I remember what I want. I have A in the forward direction. And, oops, I should have hit the enter key. A in the reverse. And so we actually want both of them to be 0. And if you think about it, notice they're both negative because that's because the let's get the pictures. They're both negative because if I have a slight tilt, so that's exaggerated. If I have a slight tilt, that means that we have an extra acceleration like that. So if we start the sled from left to right, the acceleration is going to be in the rightward direction, and it'll speed up. And if I take the sled now and start, oops, okay, that's not going to work. So if I have a slight tilt, and let's say it slowed down, so let's say we have some acceleration from the tilt is actually in our example to the left. That's acceleration from tilts from not being level. So when I go from left to right, it's going to slow down. And when I go from right to left, I'm going to speed up. Now, ideally, if this equals 0, then when I send the sled off, I shouldn't see any slope. So we want this to equal to 0. So in this case, we notice that, in fact, they're not both 0. And, but they're not even equal to each other. Hold on, now I want to add some decimal places. And why could that be? All right, so what happens is I played a little trick on you when I, and not exactly, because I wanted to just dramatically demonstrate things. And so put borders around that. So let's take a look at this one. So I made a copy, I put different data in, and I still get the same values, but notice that these are not optimized anymore. So let's see. So this one looks like it's going to be, I want to get rid of that. So, and see, spot on. And what about this guy? And I think, all right, let's make that positive because it's, now look at that. So I see what's going on. This has to be the other way around. Give me a minute. No, that's all right. This is fine. So notice that now they're equal to each other. So in fact, the difference should be 0. So I got the order of this wrong. So it should be, wait a minute. Let me think about this for a minute. Right, I don't want to make the difference. I want to make the sum. So that equals this plus that, and it's 0. All right, what is going on here? What'll happen is that this is the ideal condition that you had at level, because you see the accelerations are equal and opposite. And how could that be? Well, that means that there's just a tiny bit of friction still. And so even though we hope that this is a frictionless surface, that there is a little bit. And we'd notice if we set this thing going, if we had a really long one, we'd notice that it would eventually slow down. And in fact, there's other things like variation of wind in the room or something like that. So even if you get a slight amount of residual acceleration, so in this case, now let's see, this has to actually be equal to the sum. So let's, this plus that. So that's negative. So you see, what that tells us is that there is a little bit of actual tilt. The difference, the sum tells us there's a little bit of actual difference. The reason is we use sum is because the acceleration from friction is always going to be opposite to the direction of motion. So it's always going to be negative in this case. It's always going to slow the object down. Oh yeah, and I forgot to, did I get the, right, so in this case there's a tilt and there is some friction, and in fact that's why this one is larger than that one, because in this case the friction and the tilt are both pointed the same way. So if I go from left to right, it slows down faster. Whereas in this case, the acceleration of the tilt is opposite from the friction, so it's less. And in this case, the object is speeding up, and which makes sense because we're going from right to left. So if it's perfectly balanced, now we notice that this one is slowing down, and so is this one. Even though it's a positive slope, it's going towards 0. So in this case, they're both slowing down, and the sum is equal to 0. So that means there is no net tilt. But because these two guys are not 0, that means that there's still a little bit of, excuse me, these are not 0 because of the friction that might be present or other things going on. But because the sum is equal to 0, we know there's no tilt. Now, it's not likely that you're going to get it to be exactly 0. So what it turns out that we're going to be measuring an acceleration of gravity that's actually much greater than whatever residuals we have here. So once you've got it all set up and you think it's level and you do your 2 runs, you don't have to say, oh crap, I didn't get it 0. And we'll be able to justify that later on. Now, here's the nice thing. You can now have, you're going to be doing, I think, only 4 runs, yeah. So what you can do is you can just create copies of this. So, for example, well, and first of all, so let's say we have, this is the level track. And so we can rename this, right mouse click. So we call that level track. And then we just go here, and I'm down here. I right mouse click, move or copy. And so before sheet here, because you won't have these other two, create a copy. And now this is the tilted track. And you're set. So you take your data for run 1, run 2. And the lab says there's only 6 gates. I don't know. So you type in all this stuff. And you'll have your graphs, everything will populate. You'll have to tweak these numbers, the slope and the y-intercept, and until you get the actual numbers, and you'll be good to go. So get this set up, and you'll be ready to take data and just do, you want to just do a preliminary check before you go on. Let me think about this. Why? What do we need to? Oh, this is just to show that. So they also want us to make the distance time graphs, and so to show that the velocity is constant or not constant. But we'll leave that to another time.